4.5 is on graphing sine and cosine functions. Alright, here are the quadrant angles of a unit circle going from 0, pi over 2 pi, 3 pi over 2 to 2 pi, right? You have 1, 0, 0, 1, negative 1, 0, 0, negative 1. Recall that your cosine are your x coordinates, right? And sine theta are your y coordinates. Let's go ahead and make a table for y equals sine of x. For your input, right, notice that we have angle measures here. So we're going to go ahead and put 0 radian, pi over 2, pi, 3 pi over 2, and 2 pi. And notice that from here it's going to repeat itself because, its coterminal angles are repeated every 2 pi. So remember, for sine, it's the y coordinates. So my y coordinates will be 0, right? When sine of pi over 2 is 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and then sine of 2 pi is again 0. I went ahead and labeled the x-axis using 0, pi over 2, pi 3 pi over 2, and 2 pi. And let's go ahead and label the y-axis. We're going between 1 and negative 1, so I'll go ahead and mark that there. Now if I actually plot these points, I get 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, negative 1, 2 pi, comma 0. So I went ahead and made a smooth curve going through the points, and this is the basic shape of my sine curve. Notice that we go through an intercept, then we have a maximum point, we go through an intercept, the minimum point of the graph, and then back to the intercept again. So we have 3 intercepts for a sine function. And again, these are going to repeat, right? Because sine theta, right, or sine of x, right? The values are going to repeat every 2 pi, like every one revolution, one full revolution, or every 2 pi radians. Your y values or your sine values are going to repeat. So you're just going to keep having these curves here. It goes on forever in either direction. But this one little section here, that is called one cycle or one period, because that's the little piece that repeats itself. What would happen if I made this a negative sine of x? What would happen then? Right, that would be a vertical reflection or reflection over the x-axis. So, right, it would just flip over like so, right? So that would be negative. You would go minimum, intercept, maximum, then intercept instead of max and then min. Okay, now let's go ahead and do the same for y equals cosine of x. Again, note here that your input is your angle measure and your output is the ratio. So cosine of x, if you remember, kicks there, right? In a unit circle where radius is 1, cosine is your x coordinate, so we get 1, 0. Right, cosine of pi is negative 1. Cosine of 3 pi over 2 is 0. And cosine of 2 pi is 1 again. Okay, I went ahead and labeled my x-axis and my y-axis there. So let's go ahead and plot these. Again, I have 0, comma 1, pi over 2, comma 0, pi, negative 1, 3 pi over 2, comma 0, and 2 pi, comma 1. Okay, and here I went ahead and drew a smooth curve through the points. Again, this is one period or one cycle because it continues to repeat itself on either ends, right? It's just repeats itself. Let's think about this. This is the parent function. So y equals cosine of x, you want to remember this shape. Recall that I have a maximum point, then intercept, then minimum point, then intercept, then maximum point. So for cosines, you start at the max, right, and then go through 2 intercepts, versus for sine, you start at the intercepts. Now, if this was negative, what would happen? If I had a negative out in front of the cosine of x, it would make a reflection, right, over the x-axis. So the graph would look something like this instead. Oops. So if you were sketching, you would start from the minimum instead of starting from the maximum for one period. Let's go ahead and recap the parent functions on what their graphs look like. So y equals sine of x, I'm going to have 4 intervals total and a max and a min location. For sine of x, you're going to you're going to have 3 intercepts going to the max first and then to the minimum. So these are your 5 key points for your sine graph. You want to remember this because we're going to graph this over and over again, just with differing x and y values. Let's do the same for y equals cosine of x. So for y equals cosine of x, again, I have my 4 intervals here, my max and my min. But for cosine of x, you start at the max, right, and then you go through the intercepts like so. So it would look like the following. So that's one cycle. That is the parent function graph or sketch that we will use. Again, notice that I have 5 key points. 1, 2, 3, 4, 5. You start at the max for positive cosine, you start at the minimum for negative cosine. Each time you cross through, right, each time you have to go through the intercepts. Do you see that you have to go through the intercepts to go onto the other side of the x-axis? So these are the
Okay, 4.5 graphs of sine and cosine functions. We are going to look at the parent function of y equals sine of x. So input is an angle measure and then output is going to be the ratio. For the warm-up, I had you guys fill out a chart, right, from going from 0 to 2 pi, all the quadrantal angles. You can see that 0, pi over 2, pi, 3 of pi over 2, 2 pi. And let's take a look at what that looks like if we were to actually plot it. So in the y direction, I'm going between 1 and negative 1, right? It's alternating between those. And then in the x direction, okay, I'm going 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And then if I just plot the points, right, plot the points for sine of x, it was 0, 0, pi over 2, comma 1, pi, comma 0, 3 pi over 2, negative 1, and 2 pi, comma 0. Nod your head if you're okay with this, right? Remember the table that we made for the warm-up? We're just plotting this. Okay. So I want you to remember, like, sine at the line. When you sine things, like you sine at the line here, right? So with a sine graph, you want to remember that you start at the line being the x-axis. Okay, and then we're just going to connect this in a smooth curve here. Okay, and then you put double arrows, right? Arrows on either side because they continue forever, right? They just keep going the same shape. But this, bless you, is one period. Or this is a period, right? This is a period where it's one unique cycle. Okay? So it's the unique portion of a graph before it starts repeating itself. So length of one cycle. So in this case, the period is 2 pi long, right? It's 2 pi. It's going from 0 to 2 pi. Okay, what would happen if I had a negative sign? What would happen? It would just flip over. It would go to the minimum first and then to the maximum. Instead of here, it's going to the max first and then the min. Let's do the same thing now for the cosine graph. So y equals cosine of x. Again, that is your parent function. Okay. So again, based on the chart that you made on the warm-up where you find the xy coordinates going from 0 to 2 pi, we found that we're going to be between negative 1 and 1. And it's going pi over 2, pi, 3 pi over 2, and 2 pi, right? The quadrantal angles, we're just going through the circle. And for this graph, for the cosine graph, when x equals 0, what did your y equal? 1, right? So see how, unlike the sine graph where you sine at the line, right here you start at the maximum, okay? So you start at the maximum, then you go through the intercept, minimum, intercept, and maximum. I'm going to go ahead and connect these. Right? And then maximum, and then it'll come back down because it hits the max, and then it comes back down again here. Again, it repeats forever in both directions. So cosine graphs, you start at the maximum. But if this was a negative cosine graph, you would start at the minimum, right? And then intercept, maximum, intercept, minimum. Okay. All right, so let's consider the transformation here. I'll just do it for the sine graph, for the sine function, but it's the same for cosine functions as well. So if I have a sine of b times x minus h plus k, okay, what does that k do? Up and down, right? It's the vertical shift up and down. Okay, so that's up and down. What about the h? What does that do? The left or right, right? It's opposite of the sine, right? So it's left or right, okay? And then how about this a here? Yeah, it's the vertical stretch or shrink factor, right? Vertical stretch or shrink by a factor of a. And if a is negative, it's a reflection over the x-axis. It's a vertical reflection, so it's a reflection over the x-axis, yeah? The y values flip, right? If a is negative. Okay, the one that's a little tricky is this b right here. That's the what kind of stretch or shrink? Yeah, it's horizontal. So this is a horizontal stretch or shrink. And then the factor, right? It's not b. What do you multiply by? Do you remember? The reciprocal. Very good. It's the reciprocal. So you multiply by 1 over b. So remember the horizontal ones are like counterintuitive, or they're inverse operations. So when it's like minus, you're actually going right. If it's plus, you're going left. When you're multiplying b, the effect is dividing by b or multiplying by 1 over b. You see that? So horizontal stretch or shrink by 1 over b. And then if b were negative, right, so b is less than 0, then you would reflect over the y-axis, right? It will be a horizontal reflection. Anything that's happening on the inside of the sine function or the cosine function, it's a horizontal change. Anything on the outside of the sine function, it's going to be a vertical change. Nod your head if it's kind of coming back to you, right? We've done this for the other different functions. Okay, the way that it's going to be given to you, though, like instead of the b value being factored right here, the problems that are given to you, it's going to be not factored. So y equals a sine of, let's see if I like multiply that out, bx minus bh plus k. So this is the format that you're going to see the problems given to you, and then you can go about it differently. You can either write it so that it's like the b is factored out and you see the hk right away, or you can use a different approach for the horizontal shifts here. Okay. So this a value, you know, the vertical stretch or shrink factor, right? That is also known as the amplitude. Amplitude, so it's the vertical stretch or shrink factor, right? But it's going to be the absolute value of a.